Hi everyone, hope you all are good. So, we're here for grade 9 math. We're working on the book Principles of Mathematics, grade 9. We're working on chapter 7, that is properties of 2D figures. Lessons we're going to cover today are exploring quadrilateral diagonal properties and reasoning about triangles and quadrilateral properties. So, let's just start with the lessons. Okay, here I'm on grade 9 math. The chapter name is 7, chapter 7, and lesson we're going to start with is exploring quadrilateral diagonal properties. So let's just start with the lesson. There are different types of properties. Kite, a quadrilateral that has two pairs of equal sides with no sides parallel, right? You have pairs of equal sides and no sides are parallel. What is conjecture? Conjecture is a guess or prediction based on limited evidences, right? Okay, so here it is. You can see this is parallelogram, rectangle. Then you have rhombus, square, irregular quadrilateral, trapezoid, isosceles trapezoid, and kite. So isosceles means having two equal sides. Triangles can be isosceles and so can trapezoids, right? Isosceles triangles are isosceles and also the trapezoids, right? Okay, the diagonals of certain quadrilateral have special properties, right? Let's just read the properties. Square. Square, the diagonals are equal and bisect each other. The diagonals form angles that are 90 degree, all 90 degrees, right? So all diagonals are 90 degrees and the diagonals are equal and bisect each other. Then rhombus. Rhombus is not a square, right? And are not equal and bisect each other. And all angles are 90 degree. Rectangle, also not square. So rectangle are equal and the diagonals are equal and bisect each other. The diagonals form angles that are equal and supplementary when adjacent, right? Then you have parallelogram, not a rectangle or a rhombus. The diagonals are equal and bisect each other. For a parallelogram, the diagonals are not equal and bisect each other. The diagonals form angles that are equal when opposite and supplementary when adjacent. Same is for isosceles trapezoid. The diagonals are equal and intersect to form two pairs of equal line segments, right? The diagonals form angles that are equal when opposite and supplementary when adjacent. Then you have kite. The diagonals may or may not be equal and only one is bisected by the other. All the angles are 90 degree. You can identify the type of quadrilateral by using its diagonal properties, right? Okay. Okay, let's just see the practice questions. The first one is each quadrilateral ABCD below has three vertices 0, 0, B, 3, 4, and C, 8, 4. Use diagonal properties to identify the coordinates of the fourth vertex D in each case. Okay, so if it is a rhombus, so rhombus is a parallelogram, right? We can find the fourth vertex based on the difference in coordinates, right? hold on. Let me just draw the points on the board. A is 0 0, B is 3 4, and C is 8 4. Okay, A is 0 0, B is 3 4, and C is 8 4. Okay, you have to find a third, the fourth vertex D in case of these three types, right? The first one is, okay, the first one is rhombus. How do you find the fourth coordinate? Okay, so the rhombus is a parallelogram. We can find a fourth vertex based on the difference in coordinates, right? The y coordinates of B and C are, the y coordinates of B and C are same, right? That means the line segment that connects B and C is the horizontal line. And the difference between the x coordinate is 5 units. That means the difference between the x coordinate of A and D is also 5 units. That means for a rhombus, if A is 0 0, like this is the vertex 0 0, right? B is 3 4, X is 3, and Y is 4, somewhere here. Then C is 8 and 4. X is 8 and 4, like this, right? It would be like this. You have to find the fourth vertex, right? So you can see this is 3 4 and this is 8 4. If you just look at their 4 and 4, the coordinates are same. But if difference between the x coordinate is 5, right? That means the next one here would be, this one is 5 and 0, right? Okay, then you have the isosceles trapezoid. Okay, you have to find the fourth of trapezoid. Okay, since the trapezoid has one parallel of parallel sides, right? Then we know that the segment that is parallel to BC is the segment AD for the trapezoid. That is for the trapezoid, right? For the trapezoid, BC is parallel to AD. So the y coordinates of D is the same as the y coordinate of point A, right? That means the y coordinate of point D is also 0. Since the diagonals of an isosceles trapezoid are the same, then the distance between the coordinates of point B and D is equal to the distance between the point A and C, right? So C is the difference of x coordinates, which is 8 units. Basically, if we draw a trapezoid, it would be like this. Here you have 0 0, right? Then you have, for example, 3 4 here, and then you have 8 4 here. This is A, this is B, this is C. You have to make a trapezoid, right? The difference between 8 and 4 and 4 plus 4 is, 4 minus 4 is 0, right? And 8 plus 3 is 11. It would be like here, 11 and 0, right? You can find the same way the D coordinate of the next one, right? Let me just move on to next question. The next question is, match each pair of diagonals with its quadrilaterals. Explain your reasoning. Okay, so you have to match them, right, with their diagonals. So A is square, square goes with 3, right? Because all diagonals are equal and cross at right angle for square. So A is 1 2 and 3. Okay, for B, B is the kite, rhombus, right? So its diagonals are not equal, but they cross at right angles. So it would be this one. No, this one. It would be 5. For B, it is 5, right? For C, C is a trapezoid, right? So the trapezoid diagonals are equal and intersect to form two pair of equal line segments, right? It would be equal line segment. It would be this one, 1. For C, it is 1. For D, D is a parallelogram, right? For a parallelogram, it would be 2. For E, it would be 6, and for F, it would be 4. Okay, let's just start with question number 3. Explain why the quadrilaterals. Okay, explain why the quadrilaterals are in different parts of the Venn diagram. Refer to the properties of sides, angles, and diagonals of the quadrilateral, right? So you have to basically explain the details about the quadrilateral. Basically, all specified geometric figures can be classified as quadrilaterals. They all are the quadrilaterals. The figure which is isosceles from the other is a geometric kite, because just kite is, you can see, just kite is uh, separate than rest of the things, right? Because it is the only quadrilateral that has two pairs of sides that are same and has no pair of parallel sides, right? Okay, to a figure to be a square, just look at the square. It is necessary to have two pairs of parallel sides and all sides to be the same length. Since a rectangle and rhombus also have two pairs of parallel side, a square is also a type of rectangle and a type of rhombus, right? So square is a type of rectangle and rhombus. That's why square is in the common portion of rectangle and rhombus. Okay, a square is always a rhombus, but a rhombus does not always have to be a square, because the angle do not always have to be 90-degree as in the case with a square. Since there are two pairs of parallel sides, we can say that it is a parallelogram, right? A trapezoid is a figure that has one pair of parallel sides, so it is not a parallelogram. And an isosceles trapezoid has one pair of sides that are the same length, so there is a separate group of trapezoids, because it is not the rule that there are a pair of sides that are same length, right? Okay, just look at the question number 4. The diagonals and the sides of a quadrilateral forms four triangles. Complete a table of the triangle formed by these quadrilaterals. Okay, in a square you have two congruent triangles. You have to see how many number of congruent triangles in a square has. Square is a figure that has two pairs of parallel sides and all angles are 90-degree. The diagonals are equal and form 90-degree. So that means there you have four triangles, right? Then you have rhombus. A rhombus is a parallelogram that does not have to be the same angle measure. So diagonals form four triangles. You have four triangles in the rhombus also, right? In a rectangle, you also have four triangles. In a parallelogram, you also have four triangles. In isosceles trapezoid, you also have four triangles. And in kite, you also have four triangles. That means the number of congruent triangles in square, rhombus, rectangle, parallelogram, isosceles trapezoid, and kite are four, right? Reasoning about triangles and quadrilaterals properties. Okay, what is the mid segment? A line connecting the two, a line segment connecting the midpoints of two adjacent sides of a polygon. That would be the mid segment. That is a line that connects the midpoints of two adjacent sides of the polygon is known as mid segment, right? A line drawn from the vertex of a triangle of to the midpoint of the opposite side is known as median, right? Examples can support a conjecture about a geometric relationship but do not prove it. You only need one counterexample to disprove a conjecture about a geometric relationship. Mid segments form a parallelogram. The parallelogram, trapezoid, and irregular quadrilaterals. Okay, mid-side form a rhombus rectangle. Okay, predict whether a polygon's sides are all equal if its interior angles are equal. Support your conjecture with example. Polygon sides are all equal. Support your conjecture with an example. Okay, you have to see if the interior angles of the polygons are equal. That means all the polygon sides are equal, right? So let's just start with a square, right? If square has all four sides equal in length, also their interior angles are equal. But with rectangle, rectangle has the side lengths are not equal in case of rectangle, right? But they have the right angles, right? That means this conjecture is false one. Okay, the next one is predict whether a polygon's interior angle are all equal if its sides are all equal. If the side lengths are equal, do all the angles are equal? Some of the polygons do have same sides, like, right, that are equal in length, triangles, squares, and hexagons. But a polygon that also has all sides of equal length is a rhombus, but it is not ruled that the rhombus has all angles of the same measure, right? Rhombus has all sides equal in length, but not all angles, right? So this conjecture is also false, right? Okay, the next one is create a conjecture to predict the number of diagonals for any one vertex of a convex polygon with n sides. Support your conjecture with example or disprove it with the counter example. Okay, so the number of diagonals from one vertex of a polygon is the number of sides of a polygon is reduced by 3, right? That means the number of diagonals should be n minus 3, right? If the polygon has 8 sides, then the number of diagonals should be 8 minus 3, that equals 5, right? If a polygon has 7 sides, right, it would be n minus 3. That means if a polygon has 7 sides, it would be n minus 3, that is 7. That 7 minus 3, that means 4. That means the number of diagonals should be 4, right? Okay, the next one is test this conjecture. If the mid segments of a quadrilateral form a square, then the equilateral is itself a square. So you have to see the midpoints, mid segments of quadrilateral. Okay, you have to see the medians, the mid segments of quadrilateral form a square. Okay, let's just go see quadrilateral. Where is quadrilateral? Here is quadrilateral, right? You have to make a quadrilateral. Here is the quadrilateral. That would be a square, isn't it? So you can try to draw a quadrilateral around an already formed square, right? If you have already a square, you're going to make a quadrilateral around an square. Each vertex of square is the midpoint of the segment of quadrilateral, right? You can see the trapezoids form a square, right? Also, the rectangles form a square. That means the assumption is not correct. The conjecture is not correct, right? Okay. The next one is test this conjecture. The medians of a triangle always intersect at exactly one point. Yes, they intersect at one point. Yes, you can make triangle and draw medians. For example, you have a triangle like this. That is a median from this side to opposite one, right? From here to this one, from here this vertex to this one, and from this vertex to this one, they intersect at one point, right? So yes, this is a true conjecture, right? Okay, the next one is create a conjecture to predict the ratio of the area of a triangle to the area of the shape formed by its mid segments. Support your conjecture. Create a conjecture to predict that the ratio of the area of a triangle to the area of the shape formed by its mid segment. Support your conjecture by example or disprove with an. So if you draw the middle segments of a triangle, it will form four triangles, right? So the ratio would be 1:4. You can make four triangles, four triangles inside one triangle, right? You can see this one. Here is a triangle, right? Here is their midpoints. Just draw the lines to connect their midpoints. This one, then this one, and this one. You can see one, two, three, four triangles, right? So the drawing confirmed the assumption. So it means the ratio 1:4. The ratio of the area of triangle to the triangles formed by joining the middle segment is 1:4. And yes, that is the correct one, right? Okay, the next one is test the conjecture. It tests the conjecture. It is always possible to draw a circle through all four vertices in a triangle. Yes, it is. If you draw a triangle, if we draw a circle and use any 4 points, you will have a rectangle. Geometric relationships and properties are often discovered using conjectures and counterexamples. Describe the process you can solve geometric problems using words or diagrams such as flow diagram. So once you have assumed that geometric relationship, since only one inaccurate proof is enough to refute the assumption, first try to prove that the assumption is not correct. If you have not been able to prove that the assumption is not true, it means that your assumption was true, right? If you find proof of the assumption is not correct, it is used to reevaluate your original assumption. Question number 11 is create a conjecture to predict that the mid segments of pentagon form regular pentagon. Support your conjecture with example and disprove it with a counter example. So if you merge the middle segments of the pentagon, a pentagon of the similar sides, design will be formed, only of different dimensions and orientation. So that means if you merge the middle segments of the pentagon, they form the same pentagon that would be original one. Okay, the next one is draw the inner quadrilateral of a square using its mid segment. Then draw a new inner quadrilateral inside that one and then another inside the second. Do the same for a rectangle, a rhombus, a parallelogram, a kite, and trapezoid. Did you notice any pattern? Begin with a conjecture, either support it with example or disprove it with a counter example. So the assumption is that the second figure we form within the figure formed by the middle segment of the original figure will be of the same orientation and design, right? Let's just see if you have a square, right? If you join their midpoints, if you make the mid segments, And if you make another one inside, so it would be half the. If you draw another one inside, that means that would be exactly same like the first one. Okay. Okay, you can complete send by yourself later today. Okay, so we're working on. Grade 9 math. We're working on the chapter 7, that is properties of 2D figures, and the lessons we have covered are exploring quadrilateral diagonal properties and reasoning about triangles and quadrilateral properties. Okay, so if you have any question, you can please ask. Okay, so if you have any question, you can please ask. Okay, okay, so no questions. Then that's all for today. See you in the next session. Bye, everyone.